Here you go. Alright, let's start. There were 4 problems. The first of them is very easy, and there are multiple solutions. I went with something that has very long implementation, but now I will suggest something better. And in this first problem, we need to remove one element to make everything increasing. If there is one odd element, we should remove it. Then the logic I tried, because of low constraints, everything is up to 1000, is that I try to remove every element. I got rid of it, I looked at the new sequence, and I checked if it's increasing. The complexity is obviously n squared, because for each element I consider removing it, and then I go through the whole sequence. So that's of n squared if you separately consider removing every element. But instead what you could do is go through the sequence from left to right, and the first time when you see a drop, like here, after 10 there is 5, you know that one of them must be removed. If you leave 10 and 5, something will be decreasing, or actually non-increasing. So we should consider removing those two, so 10 and 5. And in both cases you could literally erase this element and look at the remaining vector and just verify it. Then it's already O of n. And also instead you can go from the left as far as possible to get increasing prefix. Go from right to get suffix, that is, well, decreasing from the left, and then look at those two lengths. Then such a candidate you can verify in constant time. But I think it's unnecessary. So just find the first drop, consider those two candidates, and for each of them, remove it, check if the remaining sequence is increasing. And that's everything. Any way to know what is the time limit for a LeetCode problem? Not really, but it should be around 2 seconds. If the constraints are up to 1000, then n squared is okay. I here lost a minute compared to some easy solution. If you look at my times in the final leaderboard, then I solved the first problem in 2 minutes. That's just like the winner, but it was possible to get it done in, I think, below 1 minute. I see here 1 minute and 19 seconds, but I thought there is also something below 1 minute. Yeah, 50 seconds. Somebody solved it in 50 seconds. Maybe it was in Python. Actually, we can look at the code. It's in C++. Alright, I see. So he considered removing every element. Just now without I, he goes through everything, but uses last helper variable to make this code shorter than mine. Okay. So iterate over I, the element to remove. This is flag, boolean flag, to check if everything is alright. If not, we will mark it as 0. Go through all elements other than element I, and always compare the current element A of j with the previous element, last. If this is not greater than last, then this is bad, mark the flag as false, and other than that, mark that last was this one. So it's like my implementation, just smarter and thus shorter. Can you rate coach of today's question? I didn't see them, so no. That was first problem. Moving on, problem number 2. And also let me put this information somewhere. Say here. It will be later easy for everybody to find what I'm discussing. No, problem B. From a string we need to repeatedly remove some substring, its leftmost occurrence, and the limits are up to 1000. Now, I think that my solution is actually cubic, but it's hard to construct such tests. And also, it was supposed to be an easy problem, so I assume that the brute force is good enough. I didn't even think I didn't even think about the constraints or the time complexity. So what did I do here? Well, I repeatedly went through the string, and at each position, starting from, let's say, this A, I saw if we have the occurrence of this substring we are looking for. If yes, we literally erase it. Erasing even a single element takes linear time for C++ string because automatically all elements are shifted to the left. So single erase is O of n, no matter how many elements you erase. We will repeat that n times at most. If the substring we are erasing is of length 1, then we will erase it at most n times. So that's in total n squared. But first we need to look for this substring. We try every position, like including this one, and we check if when we compare substring with some other string, we need to compare those three elements. No matter how you do it, you will take those three elements. So complexity of comparison is again O of n, or actually O of, let's say, k. This is comparison, assuming that length of this substring is k. We will do it n times because in n positions we compare. We try to put the pattern over there, and it will be repeated some number of times. Every time when we indeed erase the substring, we go again, and the number of times this can be repeated is n over k. Like if the whole string is of length 1000, but the substring is 10, then 100 times you can erase it. This is in total n squared. So actually n squared, not n cubed. And here maybe it makes some sense to look at my implementation. What did I do in C++? I had an infinite loop for just for easier for loops later. I have variables n and k for lengths of string and the substring we're looking at. At every position, at position pos, I check if substring in S, starting here of length k, is equal to this part. If yes, we erase. And in C++ there is this erase function, and you provide starting position and the length. If so, you break. Then after this for loop, you check if length of S is still the same. It's n. If so, then you can return S because it means you didn't erase anything. Like you went through the whole string, you didn't find the substring, the pattern, so you return the current one. Otherwise, the infinite while loop, while true, goes again. I mean, when I say infinite, I don't really mean infinite. It just goes forever as long as we don't realize here that actually we didn't find any new occurrence. Is it possible to do for large constraints? Maybe. Some ideas that could help in, for example, easier finding, checking if this pattern occurs somewhere is hashes, so maybe hashes, and also maybe a stack. When we go from left to right, we always add an element, and then sometimes we erase k elements, and then we insert a new one. And we always need to check if the last k elements, if they are equal to the substring, the pattern, and maybe combining stack with hashes, maybe it will give you linear complexity. So maybe I think that's possible if we use hashes and a stack. NK by building the substring one by one and deleting the end whenever it equals the substring. Oh, so just using the idea of stack, kind of, will be itself even without hashes of n times k. Oh, right. What I described was, what I described here on the right is the easiest I could think of, but indeed, let's now think about constraints like, let's say, n is up to 100,000, or let's say 50,000, and k, length of the pattern, up to 10. Can we solve this quickly? Well, for sure we can, and now we're aiming at O of n times k. This sounds solvable, right? Because always we go through this long string. Let's say the string is this, and we're looking at, we need to remove ABC. Then we go character by character, D, A, B, and always we check the last three characters, maybe they are equal to ABC. So at every position I have O of K per position. No, this is not ABC. What about this? Yes, this is ABC. And now the next, I have a pointer here for this whole string, and the pointer points to the next character to insert to my stack. And also in my stack, the last K elements, they are possibly equal to the pattern, and if so, I remove them. Here I remove them and I add the next character, that's B. We can quickly implement this. I think that's fairly easy. My stack, I will call it prefix, because really it's prefix. For every character in S, add it to this prefix, and also if the suffix of prefix is equal to part, like here we had DABC, something like that, DAA, BC. If the end of prefix is equal to ABC, we remove it. If length of prefix is at least length of this, the thing we're looking at, and substring, we just need to figure out indices of this, is equal to part, then prefix erase something. Just erase the last K elements. This must be n times K, because we have for loop of size n, and here we only use operations of complexity K. This new solution should be faster, and it will solve a problem for such constraints. Find linear? Yes, find is linear, at least if you provide a single character. If s.find, if you provide a substring, I don't know if this is possible in C++, then it would be quadratic, or actually n times K, where K is length of the pattern. Got top 50? Oh, congrats, Furry. That's a nice achievement. I think there are thousands of people participating. How many are there? Yeah, 10,000. I don't know if we should count registered, but who didn't submit anything. But at least 5,000 people got a positive score. Top 50 out of top 5,000, that's very nice. I mean, top 50 out of 5,000. What do I put here? We need to, let's think about an example. If prefix length is 10 and part.length is 3, then the positions I need are 7, 8, 9. Because this thing has positions from 0 to 9. How do we get 7? By taking 10 minus 3. So here, starting at prefix.length minus part.length. And we erase the same position. Because I use it twice, I will use a helper variable. Right, yeah. And this is now n times K. Submitting. Cool. And the code is fairly short. Any questions? Directly using s.find of part will return the iterator to first occurrence of the substring. Oh, that's very nice. I didn't know that. So thank you a lot for your comment, Malvika. And I will try to remember it. So in my first solution, the one from the contest, this one, instead of iterating over position, I should have repeatedly just use, like in while loop, I should use find. Maybe something like while true, iterator is s.find of part, and we erase starting from there. If this is s.end, return s. That's done. is this everything? I'm not sure if in erase I can provide an iterator instead of index. Let's try this. Compilation error. Sure. It is s.end. So it is this is index, not iterator. Runtime error. I messed up. What did I do wrong? Stack plus KMP should be of n, but I think KMP is built on one string, and if you remove substrings, that's bad. But you actually add character by character. Yeah, I'm not sure. I'm not good at strings. Do a -1. I need to actually... Oh, s.find. What is this? No, this is fine. Where -1 and why? Length -1. But doesn't this return it position of start of that string? Yes, so -1 if not found. Really? What is string and pause? Oh, -1. I see. So it's like this. Perfectly here we should use string and pause. I see. I see. But in short it's -1. I'm surprised how short this code is. I didn't know C++ enough. Then this becomes a direct implementation problem, and it takes less than a minute, just as long as you know your functions. So find and erase. Surprisingly easy. I thought that my solution is simple. Still, this one is better because it was n times k. Moving on. We now go to problem C. As a reminder, I got everything in 13 minutes, and I have good times everywhere. I wasn't the fastest, I was second fastest, but I got an incorrect attempt in third problem. I have here a recording of the contest. We can scroll a little bit. We see that I googled C++ substring or erase. Okay. Then there's this third problem. I will let this run. Alright. So I'm not typing, just this is recording from the contest. And we are now talking about C. The problem is that you need to erase some elements, or in other words, choose a subsequence of a sequence, and then you take first element minus second plus third minus fourth and so on. And whenever you see something like that, and assuming that you're experienced in DP, dynamic programming, it's extremely obvious that it's DP. Many subsequence problems are DP, including LIS, longest increasing sequence, or even knapsack. In knapsack we choose some elements, and then it's convenient to go from left to right and for every element decide if you take it or not. In this case, for going from the left, for every element you decide to take it or not, of course you can do it recursively, branch into possibilities, and then you have exponential complexity, 2 to nth power, but it's better to just use DP, because after any prefix, after you already chose some elements, you have some sum of elements so far, you need to maximize it, and either you chose even or odd number of elements. So for even number of elements so far, you want to maximize this, and for odd you also want to maximize it. Among possibilities where you took even number of positions, what's the maximum sum possible so far? And that's one dp value you need, and also what's in the case of odd. So such two values you need to maintain, and this is what I do in my code. I now stopped the recording, stop the video I mean, and you can look at this code and find the mistake. So this is what costed me few positions. Instead of second, I'm 5th in this LeetCode Biweekly contest. And what's already here suspicious is that returned type, yeah, it's set overflow, exactly. So I spoiled it by showing you what happens later. The returned type is long, but I only create ints. That's obviously wrong. I should have used long into positions here. So it worked for sample, obviously. I submitted, and yep, overflow. Of course, when they showed me that it's overflow, it was very easy to figure out the mistake. I immediately knew, oh, okay, too big numbers, and I needed to change in those two positions or places. So sad. We can look at the statement now and talk about some example, so how this solution works. Let's talk about 4253. After 4253, I actually don't like this example. Let's start with 52, and then we don't know what's next. After 5 and 2, you have possibilities that you took even number of numbers, 2 of them, and your sum so far is 3, and also odd number of numbers, and the sum so far is 2. Those are the only two possibilities you should consider. Sum is 5, sorry. This means that you took one element so far out of those, and that's element 5, obviously. You could take 2 instead of 5, but that's stupid, that's just worse, so you don't consider it. For even case, also you can take nothing so far, and then the sum is 0, but 3 is better. So when we're here in our DP, my two variables will be equal to this. Now what happens when I have a new variable x? Doesn't matter what it is exactly, but in general, if this is x, then what? Well, if there was some even number, some even sum, then possibly odd can become even minus x. Like whatever sum I had here, now I take x. X is, in this case, the third element taken, but it's taken with minus. So odd becomes even minus x, or we can also use the sum we already found. So it's maximum of odd and even. And even, either it's without change, either we don't take x, or we grab whatever we had the best after taking odd number of elements, and then adding x. Maybe here I should do it the other way around. Yeah, here plus, and if I took 2 elements, the third element is taken with a plus. If I took 1 element, or 3 or 5, then the next element is taken with a minus. So like that. We need to make those 2 lines. For example, of course, do them at the same time. Not that you cannot overwrite odd and then apply the next line where you use the previous value odd. This is why I use a helper variable here, not to overwrite. For example, if x is here equal to, say, 1, then what's possible? We could have sum equal to 3, and now we can take 1. So odd is maximized with 4. Right? Even plus x, this is 4, and odd gets maximized with 4, which does nothing. It's not optimal after taking 5 minus 2 to now take plus 1. Because if you want to have odd number of elements, it's better to just have 5. What else is possible? After 5, after odd number of elements taken, you can take -1. So from this comes even equal to 4, which is applied exactly here. Even gets maximized with 4, which means that this one changes one thing, it changes this 3 into 4, and so on. And so on. Yeah. Questions? Does it affect a lot if you declare all ints as long? It's about practice. In LeetCode, you shouldn't worry about it too much. But so long and in general bigger type is a little bit bad for efficiency. Long is slower in 32-bit systems. What am I rating? 32-bit or byte? Bit system / architecture. Obviously, it takes twice more space or memory, and it's bad practice. If you use long instead of int, and let's say it's an interview, you will be asked why. Why do you use long? And it's bad if you use something you don't need to, because it shows that later in your job also you will use unnecessary types, and you will make things less efficient. So the first point doesn't really matter too much, because modern systems are 64 bits. So and then long is almost as fast as int. Maybe there is like 5% difference. Maybe there is some difference than in cache, because in cache you can store more stuff if you use smaller types. I use int whenever int is enough, and from time to time I'm hurt, just like here, where I first typed int without thinking, and only then realized that yes, sum of all elements is n times this. So sum of elements can be up to 10 to 10th power. Will I take some questions from binarysearch.com? Not today, maybe next week. So indeed, next interview coding stream. Next Saturday or Sunday. Are we focusing on simultaneously maximizing odd and even? I don't know if a word simultaneously is proper, but yes, you separately want to know what's the best possible sum so far if you take even number of elements, and what's the best sum if you take odd number of elements. So those are two separate numbers. They are, let's say, independent. They're sure affect each other once you add an element, but yeah, you maximize even and you maximize odd. You want to know what's the best so far possible here. If you want to learn DP, at least my way of understanding iterative DP, you can on YouTube watch DP lecture on my channel. Yeah, starting with this one, DP lecture number 1, Fibonacci, and so on. Not safe. Share. Paste it in the chat. Oh, I hit the chat. Well, this is better. Right, that was third problem, see. Moving on. Q4. Q4 took me most time. You can see that first 3 problems were 5 minutes, and then for the 4th problem I needed another 7 minutes, almost 8, 7.5. What's Q4? The statement is very long, and it takes like 2 minutes to read it at least, and it takes a lot of implementation. We will not go through the statement sentence by sentence, but I will roughly tell you what's going on. In problem D. Okay, I'm ready. There was a bunch of shops. Let's say there is shop number 1, shop number 2, shop number 3, and so on. Each of them offered some movies. Movies could be repeated. And it made sense to think for every movie where it is, how to say it, available. Let's say movie of ID 1. Let's say movie 1 with ID 1. Let's say it is available at shop number 2 with price 50. And on purpose, I will do it in the other order. At price 50, it's available at shop S2. And with price 35, it's available at shop 3. Let's say it isn't available at shop 1. You have similar information for movie 2 and for all the movies. Maybe here at this with this price shop 1 and with this price shop 2. At the beginning you're given a bunch of triples, movie, comma, price, comma, shop. And what do you need to handle with that? Sometimes a movie becomes unavailable because it's rented. So you need to handle erasing something from here or hiding. Later it can again become available because somebody gave it back. It was rented, but now it's unrented. So you need to be able to cancel the renting. No new movies appear or no new pairs. So it's like, let's rent this, let's rent this, let's rent that, let's now unrent this, those kind of queries we have. And also, sometimes what happens is a query, this movie is where it is available for the cheapest price. Actually, it was more complicated. Find 5 cheapest shops where this movie is available. Whenever we see, also constraints were big, like 100,000 queries, so you cannot go quadratic. You need to be constant per query or logarithmic. Would it be possible to solve every problem in linear time? No. For some single algorithms, there are proofs that you cannot do it better than some complexity. Like there is, I'm sure you can Google prove that sorting is n log n. Oh, it's called sorting lower bound. You can read about it on your own, but some things, assuming proper assumptions, cannot be done in linear time. This is one of them. And the biggest problem is whether exponential algorithms like knapsack can be done in polynomial time. That's the famous P versus NP. Print all permutations works too, sure. So sometimes we need to find 5 cheapest shops for a movie, which strongly suggests that for every movie we need to keep things sorted. So likely this is how I keep pairs. Sorted things can be kept in priority queue or in a set. C++ set is very powerful and convenient because C++ STL set allows you to insert something, erase, and get first, so get the top element like from priority queue, but also get first few. You can iterate from the top. You can get the top 5 elements, for example, and that was needed here. What I used in this problem was a set of pairs of ints. Every pair was price, comma, shop, and for every movie I had that. So for every movie I needed set of pairs, and then, for example, you can have a map from int, movie ID, to this set of pairs. Whenever something was rented, I would erase a pair. Whenever it was unrented, I would insert it back. Whenever I need top 5, I would iterate this set. It automatically goes from the top, so from smallest elements, and I stop after either reaching the end of the set or going through 5 elements. That is enough. There was some inconvenience that whenever you get information that something is rented, you don't get a full triple movie, comma, shop, comma, price. So the query rent, they give you movie, comma, shop. That this movie was rented from this shop. So in order to really know what I'm erasing from those sets, not only I have this set of pairs, but also I have a map from pair to int. This is a map that, given movie and shop, I need to get the price. A map from pair movie comma shop to price. We first get triples, price movie shop, and from them I can create both those sets and the map. This is map from movie shop to price. Then whenever I see a rent or unrent query, I first use this map, and given movie shop I'm able to get the price. Now I know all three elements I know all three values about this movie in this shop, and now I'm able, given price as well, to erase a pair price comma shop. For example, let's say that this is rent. I get information that we need to rent movie number 1 in shop number 3. What do? I use this map, and this map will tell me in logarithmic time, it will tell me that 1, is 3, this pair movie comma shop is at price 35. Cool, now I know the price as well. So now I grab the price and the shop ID, and this pair I need to erase from the first set of pairs, because that's for movie 1. It's for movie 1. So I look at the first set and I erase a pair 35, 3. So that's how we solve the main part of the problem. For every movie answer, for given movie answer query about top 5 places to buy it cheap. And there was second part of this problem. What else? Returns a list of cheapest rented movies. I will not discuss it because it's the same. We have a set of cheapest rented movies, just one set. This part was easier. I think the problem should just focus on the initialization, and then renting, unrenting, and searching top 5 for a movie. This was just boring to add it. And I used the set. In Python you don't really have that. In Python you would need to use some kind of priority queue, but priority queue doesn't allow erasing. If you use a language where you don't have access to convenient data structure that in logarithmic time is able to insert or erase an element and always keeps stuff sorted, it cannot be, for example, just an ordered map or an ordered set, hash set, because things need to be sorted. If you need to use, what am I saying? Not priority queue, priority queue. I'm stupid or something. Okay, priority queue doesn't allow erasing. You can erase in lazy way. Instead of literally erasing, just store in some kind of hash set information about a need to erase an element. So how to erase from priority queue. Create hash set of elements waiting to be erased. And now, whenever you want to get the top element from priority queue, you don't just get top element from priority queue, but instead multiple times you look at it and a top element in priority queue, and you check if it's in this hash set of elements waiting to be erased. If so, you erase it. So you just pop the top element. In this way, you can lazily erase from priority queue. The space complexity grows a little bit, but it's still linear, with some waste, of course. Other problems about more advanced ways to erase, and the most well-known is LRU cache. I recommend that one. I struggled with this to get the best possible complexity without any unnecessary logarithms. If we were asked to find the cheapest shop for an interval, how would we do that? What does it mean for an interval? You mean interval of movies? I would check each movie separately. I don't know how to do it better. Maybe some kind of segment tree allows that. But segment tree should be beyond the scope of coding interviews. Big statement, I wouldn't even read this. If this allowed you to get into Google, I think you would read it. C++ is indeed amazing. It's very convenient. Third was the same as this. Pokemon Army in Code Forces. I can believe that. The simpler the statement, the bigger probability that it was already used. For a problem as simple as LeetCode C today, I'm sure, even without you showing me this, I'm sure that at least twice or 3 times it appeared in various platforms. Maybe even including LeetCode. Code Forces, Topcoder, CodeChef, there are tens of platforms. And for sure somebody already came up with this idea. Tried submitting my AC solution and now gives time limit exceeded. Your rank cannot differ if you resubmit it after the contest. I don't know what happens during the contest. Read for Google, but not for Amazon. Okay, now I believe you. Crying, I wrote 30 lines. What do you mean? Why is it crying? In this problem, I wrote 50 lines. Submitted after the contest. Then nothing to be worried about. By the way, if the same code now gets time limit exceeded, then either the time limit was changed, or maybe you were lucky the first time and you are very close to getting accepted. Maybe resubmitting a few times, sometimes you will get AC, sometimes TLE. Or just maybe LeetCode uses various machines to judge, and some of them are a little bit faster. That's possible too. It's not extremely professional platform. In LeetCode, it doesn't hurt that much if the times vary by like 10%, while in competitive programming platforms, it matters a lot. Because other platforms are more about contests and getting a rank. Right, so that's it for today. It was a short stream. You can expect those every 2 weeks. From now on, I will try, no guarantees, but I will try every 2 weeks to participate in Biweekly, and after that discuss problems. So after every Biweekly, go to my Twitch channel or YouTube. I always double stream here to my second YouTube channel, and we will discuss the problems together. As you saw today, not only I will show you my solutions, but also I can discuss faster possibilities or answer questions. Segment tree is beyond the scope of interview? Yes, it is. Doesn't mean that it cannot appear, but given some limited time to prepare, you should skip it. And in a place like Google, you're not likely to be asked that. Interviewers will try to avoid such a question where it's very knowledge heavy. Like, people don't know segment trees. String substring problem. Order of deletion matters. I don't know if it can matter. I really don't know. Can the order of deletion matter? AA. Remove ABA. ABCA. Yes, the order must matter, because if you remove ABC in this string, if you remove the ABCA, if you remove the leftmost, you will be left with ABCA. If you remove the rightmost, you will be left with ABC. So answering your question, Yes, the order matters. You need to delete starting from the left. That was for problem B. That's problem B. IOI this year's tasks? Maybe one day, not anytime soon. Opposite of internship? I don't know. You mean, do you want an answer full-time job? So maybe if you have full-time job. Okay. Thank you all for watching and see you next time. Just quick look if other people are streaming LeetCode. Nope. Right. So bye.